Alright, for our notes on this section, we are actually going to be working a lot of the problems from the worksheet that goes with this section. So if you're planning on printing this worksheet, you may want to go ahead and do that. Or you're welcome to just write it on notebook paper. It's fine. So we're going to be doing several things from this worksheet. And let me switch over here. Oh, wait. Back here. Okay. So we are going to be solving these log equations, and we've done a little bit of this already. It's just going to get a little more complex than what we've been doing. So we've done a problem like this before. We've got log of 5x equals log of 2x plus 9, and we need to get rid of the logarithms on both sides. They both have a base 10. It doesn't say that, but we know this is the common log, so it has a base 10. So we are going to make both of these sides, well, it's not letting me write, let's see, okay, both of these sides powers of 10, and 10 to the log base 10 cancels out on both sides, so we just have 5x equals 2x plus 9, and now we just have a very simple equation to solve, so we'll subtract 2x from both sides. We get 3x equals 9. And then our last step is to divide by 3. So we're going to get x equals 3 for our answer. We do want to plug that back in just to make sure it doesn't give us zeros or negatives here. Of course, it does not for this one, so 3 will be our answer. Okay. The next problem that we're going to look at is number 5. And 5 is similar to the last problem. We've got log of negative 2a plus 9 and log of 7 minus 4a. So both of these again are base 10. So we could do 10 to the power on both sides. And we'll see that cancels out. So we get negative 2a plus 9 equals 7 minus 4a. And we're going to solve this simple equation. So we're going to add 2a. Actually, I could add 2a, but let's add that 4a so we don't have negatives to deal with. Let's add that 4a. So I've got 2a plus 9 equals 7. I'm going to subtract my 9. And that's going to give me 2a equals negative 2. And I'm going to divide both sides by 2. So a equals negative 1. Now, that answer may seem a little bit alarming because I said that we cannot take a log of 0 or a negative number. So if we look back up here, if we plug in negative 1 into negative 2a plus 9, that's going to be negative 2 times negative 1 plus 9. And that equals 2 plus 9, which is 11. So although our a is negative, the number that we're taking the log of is 11, which is positive, so that's okay. Let's double check with the other logarithm that we have here. We've got to check to make sure that whenever we have 7 minus 4a, that when we plug in 7 minus 4 times negative 1, when we plug in that negative 1, we get, again, 7 plus 4, which is 11. Once again, we do not actually get a negative number inside of either one of these logarithms, even though our answer is negative. So it is okay for this to be an answer. Now, of course, if we did get a negative number when we plug those in, then we would say that this problem has no solution. Okay, the problem that we're getting ready to do right here, I chose this one for a couple reasons. Number one, it's a little bit misleading. Number two, it is a lot different than number 5. So first of all, let me address what I find misleading. This looks like it is 2 log 7 minus 2r. However, you can't have a log base 7 of nothing right here. So really, if I was writing this equation, I would have put a set of parentheses around that negative 2r to show you're saying 2 times log base 7 of negative 2r. Now, there are a couple options for the way that you can solve this. I think that the easiest way to solve this is just to divide both sides by 2 first. It's just going to be easier if that logarithm is by itself. So we got log base 7 of negative 2r equals 0. And be careful with these because since the last couple that we did, we just basically dropped our logarithms. You might be apt to do that here, but that is not the case because we do not have a logarithm on both sides. So in this case, we need to rewrite, or we could think 7 to the power on both sides. And so negative 2r equals 7 to the 0 power. Anything to the 0 power is 1. And so we're going to divide by our negative 2 here. So r equals negative 1/2. Again, you want to check to make sure that that does not give you a negative inside of your logarithm. And since you got this negative 2 that you'll be multiplying by the negative 1/2, it does not. So r equals negative 1/2 is your answer. Now, there is another way you could have done this problem. When you had 2 log base 7 of negative 2r equals 0. This 2 right here, if you remember your properties of exponents, we could have moved it on the inside like so. And if we do that, then we would have log base 7 of negative 2r to the second, and that would equal 0. So if we look at this, if we do the same thing again, 7 to the power and 7 to the power, then we are going to get negative 2r squared equals 1. We could square root both sides, and if we square root both sides, we will get negative 2r equals 1, and then divide by negative 2. Actually, technically, when we square root both sides, we're going to get a plus or a minus. So r would equal plus or minus 1/2. Almost the same answer as we got over here, except we've got that positive. However, if we try to plug the positive 1/2 back into our equation, we'll get negative 2 times positive 1/2, which gives us negative 1. And we cannot take the log of a negative number here. So that positive we actually cannot use right there. So we would end up with the same answer as we had doing the problem the other way. We would only get the negative 1/2. I prefer the first way. I think it's a little bit easier, but you can do this the second way. All right, we're going to look at number 10. Number 10, notice you do not have logarithms on both sides, so you cannot drop the logarithms. Again, you could take that negative 6 and make it your exponent, but since you just have a number over here, it is going to be easier to just divide both sides by that negative 6. And so we will get log base 3 of x minus 3 equals 4. And so for this problem, you have to rewrite that logarithm, or you can think log base 3. So we could do 3 to the on both sides. 3 to the log base 3 cancels. We're just left with x minus 3. And then 3 to the 4th power, and 3 to the 4th power, I believe, is 81. Yes. And you could add 3 to both sides, so x is going to equal 84 for this problem. Okay, you can always plug that back in. It does not give you a negative, so this is going to be a valid answer. Let's look at number 11. Number 11 is similar to the first couple problems that we did, but it does have a little surprise right here with this square that we have here. So again, we've got log base 12 on both sides. So if we do 12 to the power on both sides, those logarithms are just going to cancel out. This leaves us with v squared plus 35 equals negative 12v minus 1. So what we're left here with is a quadratic. And we haven't been over quadratics in this class, but you go over them in Math 1, in Math 2, and again in Math 3. So hopefully you know how to solve a quadratic now. If not, it would be something good to look back over. Let's look at what we'll do. First step to solve a quadratic is to move everything to one side. So I'm going to move everything over here to the left side. So v squared plus 12v, and then I'm going to add that 1, so plus 36 is going to equal 0. And we can either factor or do quadratic formula or complete the square. I believe that this is going to factor for us. So if I put a v here and a v here, and to get 36, you could multiply 6 and 6. And 6 plus 6 is 12, so I'm going to put a plus 6 and a plus 6. So that is going to give me v plus 6 times v plus 6 equals 0. So v plus 6 has to be equal to 0. I could set both of these equal to 0, but of course they're the same, so I don't need to do that. And I will subtract 6 from both sides, so v equals negative 6. Now, as always, we do need to check to make sure that this does not give us a negative. Negative 6 squared is positive 36, so we're going to get a positive value here. Negative 12 times negative 6 is going to be positive 72 minus 1. We're going to get a positive value here. So this is a valid answer. Okay, let's look at number 20. Number 20, we have to start using some of our properties of exponents because we are going to have to combine some of these logarithms. Now, we might be tempted to try to raise everything to be a power of 9 and just get rid of all of these logarithms, but that is not permissible. If we're raising both sides to be powers of 9, we can only do it once on each side, which means we have an expression up here with a minus in it, and we cannot just cancel out those logarithms. So what we have to do before we raise both sides to make them powers of 9, we need to combine this left side so that we're only dealing with one logarithm. So when I have subtraction, that's going to be division whenever I condense those logarithms. So I could write this as log base 9 of x plus 6 divided by x. Those were our properties that we worked on yesterday. And that's going to equal log base 9 of 2. And now, because I only have one logarithm on each side, I can raise these to be powers of 9. And I'm going to get x plus 6 over x equals 2. Now, since you haven't been in real school since March, you might be scratching your head about how to solve this. Probably the most simple way, whenever you have anything in the denominator, you cannot solve for it. So since we got this divided by x right here, we need to multiply both sides by x. And what that does, this is like x over 1, so you've got an x in top and bottom that cancels out over here on the side. So you'll get x plus 6 equals 2x. And now we have a simple equation to solve. So we'll subtract x from both sides. 6 equals x. And that will work as a valid solution, so that is our answer. Right here, whenever I was at x plus 6 over x equals 2, the other way you can think about this is if you want to put that over 1, you can cross multiply. I just hesitate to teach cross multiplication because students get it mixed up and think that's how they multiply fractions, and they cross multiply when they're not supposed to. But you can cross multiply where x plus 6 times 1 would give you x plus 6, and x times 2 would give you 2x, which is going to give you the same equation that you were solving over here. All right, we are almost done. Just a couple more. All right, so we've got log base 8 of 2 plus log base 8 of 4x squared equals 1. Here we do have two logarithms, but they're both on the same side, and we only have a number over here on this side. So we are going to have to combine these logarithms first. And so whenever we're adding logarithms of the same base, we multiply the values that are inside of those logarithms. So this is going to be log base 8 of 2 times 4x squared equals 1, which of course we can write log base 8 of 8x squared equals 1. Now, to solve this equation, we do not drop the logarithms because we do not have logarithms on both sides. So we are going to do 8 to the power on both sides. 8 to the log base 8 is going to cancel. We'll just have 8x squared equals 8 to the first power, which is of course just 8. Now we're down to a simple equation. We're going to divide both sides by 8. So x squared equals 1, and we will square root both sides. So x equals plus or minus 1. So we do need to check our answers here to make sure that both of these answers will work. The only variable we have to replace here is this x, and we're squaring it. So even if that is a negative 1, it's going to get squared, which makes it positive. So it is okay to have both of these answers. They are both valid answers. Okay, 24, I believe, is the last one we're going to look at. And 24 is a natural log problem, which of course means that we have a different base. But we're going to work these problems basically the same as we have the others. So we need to combine these natural logs first. So we're going to have natural log of negative 3x minus 1 divided by 7 equals 2. Now we cannot drop the natural logs. Just remember, this natural log has a base of e. So we're going to do e to the, on both sides, e to the natural log is going to cancel. We get negative 3x minus 1 over 7 equals e squared. Now, I believe the answer key on this is going to keep the e squared there for their answer. So I'm going to solve it like that first, but you can also use decimals if you prefer. So if we're solving this, we are trying to get that x right there by itself. So I would start by multiplying both sides by 7. And so negative 3x minus 1 equals 7e squared. Then, of course, you would have to add 1 to both sides and divide by that negative 3. And let me check to see if I'm correct that problem. Yes, this problem is going to give that as the answer. However, if you're going to prefer to use decimals, that's fine also. Negative 3x minus 1 over 7 equals e squared. If you type that into the calculator, is 7.38905.6, and so on. So you can solve the problem that same way. Multiply both sides by 7. So that gives you negative 3x minus 1 equals 51.72339. Keep that in your calculator. And then you just have to add 1 to both sides. Negative 3x equals 52.72339. And then last step, divide by negative 3. So x is going to equal negative 17.574. So this answer here, negative 17.574, is equivalent to 7e squared plus 1 over negative 3. Let me look one more time here. And actually, you will see that they have negative 7e squared minus 1 over 3 as the answer. Notice that the answer that I had has a negative in the bottom and everything in the top is positive. Those are still equivalent answers because if I took this answer right here and for whatever reason multiplied the top by negative 1 and the bottom by negative 1, which I can do because that's like multiplying by negative 1 over negative 1, which just equals 1, that would give me negative 7e squared minus 1 over positive 3. So those are equivalent. So you can give any of these here as your answer. Okay. Your assignment is going to be to finish this worksheet. Please make sure that you show work. You've already got all the answers, so I don't just need you to recopy that on a sheet of paper. I want to see the work of you solving these problems, and then you will need to send me an email with a picture of that work by midnight on Friday. So please make sure that you do that for me. Thank you.